Our goal in this video is to successfully problem solve and model quadratic situations, and essentially we're converting the real world into the world of maths, doing the maths, and then communicating back in terms of the real world. So it goes sort of full circle. And here's I'd call this a medium example. It's not super easy, nor is it particularly difficult, and it depends how experienced you are, of course. So we've got a piece of wire. It's 68 centimeters in length, and it's bent into the shape of a rectangle. So what I'm going to show you at the same time too is a problem solving process which is called reciprocal maths or reciprocal maths teaching that I've used for a number of years, and we're going to sort of work between the two of them, the question and the process. Piece of wire, 68 centimeters, bent in the shape of a rectangle. So the first step would be make predictions and connect to your background knowledge. And can we estimate an answer? Maybe we can. And what units? What would we expect? Now predict, you can't get predict wrong. Predict is just to get you thinking in the right direction and get students engaged in the question. So I'm thinking we might be looking at a rectangle with a perimeter, and I'm going to draw a picture of it. Hopefully you'll use a ruler, and perimeter equals two lengths plus two widths, so it's the distance around the outside. And in this case 68 centimeters must be equal to that. So we're working in centimeters. Now I'm assuming that I'm using all of it, and it's not open. Okay, so we have to make some assumptions and with some problems. Okay, well, what else have we got to do? And A, reading on, we've got A is the area enclosed by the rectangular shape. So we don't know the area so far. Write down the formula that connects A and X. So I'm thinking also that in the predict that we're going to have some quadratic, because we're studying quadratics, A of X, which will be a quadratic formula, be used somewhere. Alright, so the second phase is to clarify. So do we understand all the language used? Clarify any words or phrases. Let's have a look. Maybe connects. What does that mean? Well, that's probably going to be a function, isn't it? So connects means it's a function or an equation, and that's what we said down there. And sketch the graph. Okay, now perhaps when we got the function, we'll be able to use our graphics calculator to do that, and then use the graph. Yes, it probably would be good if we're going to use that graph and it doesn't say we had to use any special procedure. We're going to use our graphics calculator there. So I'm clarifying what I've got to do and what everything means. What helpful information or clues is there in the question is the next bit. Alright, so well, we have a perimeter, and we know the formula for a perimeter, and we also know the value of that, so that's helpful. We know it's a rectangle, so we know it's a perimeter of a rectangle, needs to be used, or probably will be used. And use your graph to determine the maximum area, so the area must change. Now some of you mightn't realize that for a fixed bit of wire you can have different areas. Now a very powerful question that we need to know the answer to: what further information do we need in order to solve the problem? Well, in fact, what is the problem that we've got to solve? Well, we've got to find a formula come up with the graph, that's not much of a problem, and then find a way of getting the maximum. Alright, well, I guess what we need to do is come up with a formula for area, and we need to see how they're connected. So, what is the formula for area? Area of a rectangle is length by width, but we need to find an expression for the length and find the expression for the width. And another thing to clarify here is that it says the length of a rectangle. What is that? I've never heard of the length. That must mean the perimeter. Okay, so we need to clarify that. Now, students, if nobody's told you this before, it is true that true problem solving is messy. Okay, now what I've done is just made a mess of this page, but it's a good mess. Alright, and that's thinking. Always think before you go ahead and solve the problem. Now, you'll notice that with our procedure here, the whole top row is thinking. I've got the first two stages done, and do I understand what I've been asked to do and find out? Well, yes, because I just explained it in my own words. So you need to be able to do that, or you don't know what you're even chasing, and it's just a bit of a joke. So you don't want to go through that sort of scenario. So before we get to solve, we need to think it out. And I think we're just about ready to solve here. So we pretty much understand the problem. I need to find now a way of connecting the perimeter and the area, and I need to find out a way of expressing the length and the width in terms of the given information here. So, and we're hoping that will lead to a quadratic, because that's what we're expecting. Okay, so now we can work in a bit more of a tidy manner. So that's messy, but let's go a bit tidier now. So if we've got to find a way of maximizing the area, we're working with the areas formula, and area is called capital A, and A versus X, and X was the length of the rectangle. Alright, so what we have then, P, which is actually, we've been told to use the symbol X for the length of the rectangle, which is actually the perimeter, because we've bent this wire around to make it closed. We're assuming it's a closed perimeter, closed rectangle, and that equals 2 lots of length plus width, whatever they are, and that comes out as 68. So X equals 68. Or wait a minute, no, maybe I need to read that again. X is the length of the rectangle. Ah, no, it doesn't mean the perimeter, that's wrong. So you might have been watching this going, why is he doing that? I thought it was the length of the wire, not the rectangle. So sorry, X is going to be that. So there you go, problem solving is truly messy, and I'm not even going to edit this bit out of the video, I'm going to keep it there. So I need to fix this. I reckon I have put something in that's not right. So no editing, look at this. And basically, look, P equals perimeter equals that, which equals 2 times X plus W, whatever the width is, equals 68. So 2 times X plus W equals 68. So X plus W equals 34. Okay. So W equals 34. Take X. Now I'm going to need that result, perhaps. So I'm just going to call it equation 1. Just give it a name. It can be simple as equation 1. So we've also got area equals length by width. Now we said length is X and length times width. Now we've got a W there, I notice, and I think this is like a simultaneous equation, which you might have seen before. We can substitute one equation into another. You should have seen that in perhaps year 10. And basically this W can be replaced by 34 minus X. So wherever I see W, I can replace that because they're equal to each other. So I'm going to do that, and I've got A equals X times, instead of W, I'm going to write in 34 minus X. So I've replaced that W with 34 minus X. I'm going to put brackets around it, and look at that. Oh, look, because when I expand that, I get 34x minus x squared. So we've got A and X connected. We've got a function like we said we wanted to, and look at that. Now, time to get some technology and plot the graph like we were saying for part B. Now you might notice that you don't always have the best window, so this window needs to be increased a lot more. So we go window settings, and don't need anything for length less than 0, so I'll start at 0, and we need to increase this a fair bit more. I'm going to try, I mean it's a way of telling, but I'm going to pretend I don't know that. I'm going to try something bigger like 40, and I don't need anything less than 0 here for the area, and I know it's going to be big because we're timing big numbers together, so I might make that 250. Alright, and see what we got. And it still doesn't quite fit in, so you just might need to use a bit of trial and error. And alright, so there we go. We've got our graph, and so what have we got to find? Go back to the question. So we've done part A. Indeed, problem solving is messy. Done part A. We would just do a pencil and paper copy of the sketch, and I guess it's important to note we've got, be handy to know where the zeros are, so you can, if it's a technology question, you can go analyze graph and find the zeros. Well, we know what that one is. That one's 0, 0. What about this one? 34, 0. Oh, okay, that makes sense. And then what about the maximum? We could go, and this is answering part C essentially. We can go maximum there. So that means when the value for the length is 17, we have 289 for the area. So returning to the question, the sketch is from the graphics calculator in part B. We just copy that onto our book, and then in part C we're using the G-Calc. So the graphics calculator did make life easy. This could have been a much harder problem if it was a technology free question, which could be asked of you, but we used the maximum, quoting what I used, the keystrokes, the maximum function from the analyze graph menu, x equals 17 centimeters, and subbed into the area. That gives us 289 centimeters squared. So reflecting, yes, the answer does make sense, and looking at it is reasonable because, well, we've got it straight from technology. If you did this by hand, of course you could use technology to see if it's correct or reasonable and verify it. We did make some assumptions that we used all of the Y and it was a closed rectangle, and the thickness of the Y didn't stop us from doing what we wanted to do. And the skills, well, sometimes we can reflect there. What I would really like to explain is that this could have been a non-tech question. Now think of what you would have had to have done if it was a non-tech, so tech-free question. How would you have found that point there on the graph or for the function? Okay, you would have had to have found the turning point and use one of the two methods to find the turning point. Okay, so it would have been a little bit harder, and you can be asked to do that. So you need to be clear on whether it's a tech active So tech active or tech free, which means no calculators. Tech